Atul?
Hello.
Yeah, Atul. Now it's okay. Good
Yes, sir.
evening.
I think my headphones have some problem. I will connect it in 2 minutes. Give me 2 minutes.
I think now it's okay. It's coming. Okay. Ramakrishna, I'm audible. Ramakrishna, you are on here or audible or Ramakrishna, are you coming first time? So currently, which equipment you are handling then?
I mean, as I told you, we have around, I think, the current project which I'm handling, I have around 200 plus static equipments.
Oh, 200 plus.
Yeah, so we have vessels, heat exchangers, columns, reactors, filters, cyclones,
Okay, okay.
many varieties, the silos.
Okay.
I mean, mostly almost all types of equipment we have.
But which are you are handling now currently?
As I told, I'm handling all.
Okay, you are handling all. Okay. Just
All.
now, this Anshul, he's telling it's a cryogenic tank vessels and that one.
Yeah,
Did you handle
that's
that
what,
one?
yeah. Cryogenic seems interesting. So,
Okay.
so but, I didn't do cryogenics. I mean, I didn't come across any so far. Yeah.
Okay.
Yeah, actually, cryogenic sector is also on the boom because of green hydrogen, the ammonia supply and all that. So hydrogen tank needs to be made. That is why these days cryogenic demand is increasing.
Okay.
But
Yeah.
I've left the cryogenic sector. I'm in oil and gas right now.
Okay, now you are in oil and gas. Okay.
Yes.
Why you are booming sector you left and you are going to oil and gas?
No, actually, no. The concern is with cryogenic, the only material you can work is SS or aluminum.
Okay. Some
You
duplex
won't get
also sometimes they
exposure.
use, no? Duplex material.
Actually, in tank, we don't use duplex because our temperature is minus 196, so we need the impact there.
Okay.
Yeah. Duplex generally becomes brittle at that temperature.
Yes.
So
we only use austenitic.
Because of presence of carbon.
Yeah.
Okay.
So austenitic is the better for us.
Yeah.
Even in that
300 series, 300 series is the best one.
Yes. Even in that only four component 304L, 304, 316 and 316L.
Yeah.
Okay. So if they are using this only 4 metal, then why? I mean, due to this material you left this field and you are going to some other field like that?
Actually, I wanted to have more experience on the material plus the other products that are being developed in oil and gas. You can't be a static designer with just one single kind of product. No? That is why.
Okay.
Yeah.
So this is booming, but you want to get some other experience also with some other field.
Exposure. I mean,
Okay.
the gate will over there will always be open now.
Yeah. Okay.
I have left with that much sincerity from there.
Okay.
So that won't be an issue. But ever since I left, I have come to know about NACE requirement, LAS, LTCS, ink alloy material I have worked. So, yes.
So can you tell why when it's LTS and that one is required because to know others also on this one?
Okay. See, the thing is, LTCS is just carbon steel for low temperature.
Okay.
Impact tested material. Yeah, they generally use that term, but even I don't get why particularly we have to use that. So LTCS is just carbon steel for that is going to be for low temperature. LAS in our company is being used for reactors and columns where mostly NACE requirement where there is, they generally prefer to go with chromium moly steel, especially in the they are designing coke drum here also, so that requires material in the chromium moly range. So yes, material was one of the specifications. We have to use the material for up to 800 degrees Celsius.
Oh, okay.
That is where the customer plus the non-corrosive property of Incolloy.
So what is this? Incolloy. Okay.
Yeah,
Inconel.
Incolloy.
Inconel.
Yeah, but Incolloy is nickel plus other alloying element in a low quantity nickel. Inconel is something that is higher in nickel quantity.
Okay. Yeah.
Yes.
Okay, so when you use the Inconel and that one, on that time it's for higher temperature and that one will...
Non-corrosive. When there are corrosive surface, extremely corrosive, and you don't want to give that much corrosion allowance or don't have enough space, utility or anything to have a weld overlay.
Mm-hmm. Okay.
That is when we are using that.
But the cost of that one is more, no?
Very much more. Think about it. Like, I don't remember the exact quantity, but 600 gasket of 12-inch costed at 4 crore.
Oh, so only gasket cost 4 crore, then again equipment cost.
Yes. Yes.
Okay. So very...
Anshul,
Yes, sir.
I mean, you were saying that, they say LTCS, but I don't know why you were saying, can you repeat the question?
I said LTCS is just CS with lower temperature.
Oh, sorry,
Yeah.
disconnected. Can you repeat? I mean, where you have...
The thing I was saying is low temperature carbon steel is just carbon steel for lower temperature service.
Correct.
Yes, normalized, impact tested. Yes,
Yeah.
not much of a difference. Yes.
Actually, you were saying, I don't know why they will say LTCS, something.
Yes. The terminology by we have to create another one. That is, I was saying.
LTCS actually, it's basically LTCS is should have a toughness. When the temperature goes below, so generally material becomes brittle, and so it will fail. So this, only thing for the low component temperature is that we'll ensure that they will check the impact testing, do that, and they will ensure that this metal is suitable for that temperature. So that's it. So that they will establish that based on the experience or from this, doing the impact testing, they will ensure that this suits for the temperature. So that's why it is called low LTCS.
Yes, but they did not create that terminology for SS. In SS, minus 196 is generally the cap for impact test exemption, but after that you have to do impact testing. For helium and hydrogen tanks, impact tested SS is required. So
no, that's why if you see the UHA clause, UHA in section of division 1, so -1 up to minus 196 you can use this
material without it.
Without 300 series, that you can use. So if you are going further below, then you need to do the impact testing.
Yes.
So that is
yes.
Actually, basically to ensure that whatever the desired low temperature, how it is performing, and it will not fail. To ensure that they will ensure it by doing the impact testing.
Yeah, the concept of that I know. I just the terminology they have created for one, not for another. I was referring to that only. The naming.
Naming. Okay.
Yes, the naming concept I was only referring to. Yes.
Okay, so in SS metal also, after some certain temperature, minus temperature, we have to do impact testing like that. You're telling, right?
Yes, minus 196 base material, minus 104 weld kill for weld, WPSN and all that. But that minus 196 is with certain conditions.
Okay. certain
Hello,
conditions.
Arun, how are you?
Just like for carbon steel, there are ranges, ranges and conditions for which temperature you can use material. You have to refer UCS 66. Similarly, UHG 51 is for stainless steel, where you have to refer that condition are being fulfilled. Then up to minus 196 degrees Celsius, base metal toughness testing is not required. And even there is one more difference in the toughness testing criteria. In CS, you have to measure the joule impact energy.
Okay.
Right.
Okay.
In stainless steel, the criteria is for deflection.
Okay.
Yes.
Deflection and
Yes,
elongation.
in the
also?
sense not. Yes. Elongation.
Where this requirement mentioned? I mean, is it, which clause it is mentioned? UG 84 or where it is
UH
mentioned?
51. UH 51. UG 84 is just a general concept.
No, not the concept. Actually, UG 84 says how much energy and impact energy and all it talks about.
Yes, the Chapi impact test is.
Yes, yeah, and you are saying now. So for the stainless steel, you need to do the deflection criteria. That where is mentioned?
UH 51 you will refer. There are conditions that your elongation should not exceed this much.
Okay.
In 3 tests. Minimum elongation should be this, and minimum for one. Means for all 3 batches, average should be this, and minimum for one batch, it should be this. There are certain criteria. It has been defined there. It has been defined for both minus 196 and above minus 196.
Okay. And energy also, impact energy also, or only deflection?
Only elongation criteria.
Only elongation criteria.
Yes.
Okay.
So elongation criteria normally how much? It's 5%. How much it is allowed?
No. It's in mm actually.
Okay. So how much it's allowed?
I have to check.
I think that it is a standard specimen.
Yes, a standard specimen.
So, with respect to that, it is 5 mm allowed. Maybe.
Yes.
I think specimen size will be 10 by 10 into
Yes, 10 by 10.
10 by 10 into some length.
Yes. And there are 2 elongation, one for up to minus 196 and one for below 196.
Okay.
And it's 1.8 or 3.2. He says in that range only.
Okay. Allowed maximum 1.8 to 3.2. Okay.
Yes.
So if it is clears that, if it is within that one, it's allowed. If it is crosses that one, it's not allowed, right?
Yeah.
Yes.
Yeah, I have one question.
Yeah.
Somebody can help me. So for these heat exchangers, we design test flanges are required, no, for the floating or things like this. So normally, vendor what is doing is designing using PVA light. So generally, PVA light uses the normal allowable sizes as per section 8 division 1. But
Yes.
I think it is, in the courses you can go up to 90% of yield. So
Yes.
anybody have done it, something, or how it is done? Anybody can for the test flanges?
Yes, normally for the certain sizes and for certain pressure and certain temperature, we have some standard sizes given in the TEMA.
Okay.
So if you can directly use those dimensions for the testing and test flanges. Okay. If your design parameters are out of those limits, then you need to design it. Okay, unless otherwise you no need to design the PV light again. Okay, so suppose if you are out of those limits, then you need to design in it.
No. My question is not that. Actually, vendor is using the PVA light to design the test flange.
Correct.
But test flange, if you do it in PVA light, it will take the allowable stress as per UG 23. So you will
90%.
Yeah, yes. Higher. It will use a higher allowable stress. So, but
correct.
To optimize it, we can take that allowable stress up to 90% yield. So, how generally it is done? I mean,
So extended with TKIS and we provided constraint in periodized calculation. In periodized calculation, we directly increase the allowable stress as per yield into 90%, and we did it in hydrotest pressure also.
okay.
Yes,
Okay,
yes,
so
you're right. You're right.
So you manually edited the.
Yeah, manually edited. Manually, yeah.
Allowable
Manually
stresses.
Yes.
Correct.
I mean,
You can do it in a period.
is it the right approach? I mean, maybe I thought the same idea, but I mean,
Yeah, and in this test line and test ring calculation, we did not use rigidity also,
sorry.
and we did not select rigidity also.
What is that? Okay. Rigidity check. Okay.
Rigidity check, derivation. Yes,
So
yes.
why
No need to perform that.
maximum thickness? Yeah.
Correct.
On that note, I guess ASME does not recommend to use 90% allowable, 90% yield as allowable for flanges.
No, but this is not a continuous service, no?
This is for only hydro testing.
These are not in our operation.
Yeah, this testing they are
It is
using.
only used for testing.
Testing plan, and then you can use this. And there is an option. Actually, the button is there. You can just select that for 90% yield criteria. Also, material of G5 category can be selected in the material database.
Material whatever they use is that they will select that one, but use as that flange as a testing we can use, I think, for 90%. It's not an issue.
Yes, 90% is in the design tab. There would be an option to use that.
And this is only for the flange, right? Not for the bolts.
But 4 volts we can do for 60%, I think.
No,
Yes, you can do it for bolts also.
No, what happens if you increase the allowable stress for the bolts? Again, your the bolt load will increase.
Yes.
Better to keep the same allowable stress maybe. Anyway, that already bolt size is already fixed based on your already flange of the shell. So I think.
Okay, Ramakrishna, I think you got answer.
Yeah, I got it. Yeah.
Okay.